Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and this short video, another video in our series dealing with permutations and combinations, but more importantly concentrating just on permutations and some let's say of those familiar questions that pop up with respect to permutations. So just some examples. So let's say here's another example. Okay, let's say for argument's sake that Shane has, let's say eight shirts. Okay. Let's say Shane has five pairs of shoes. And Shane has, let's say, four pairs of trousers. Okay. Four pairs, okay, of trousers. Okay. Trousers. And the question that we want to try to answer: in how many ways can Shane dress himself? So, in how many ways? Okay, can Shane dress himself? Okay, it's a bit of an unusual question, but there you go. Okay, this question is a modification of a question once again taken from the classic text and Tests, which was I suppose authored by O.D. Morris. Yeah, okay. So it's just a small modification from that. So thanks for those questions. Those questions are really very good. Okay, and very intuitive in relation to helping you to build your understanding with respect to permutations and combinations. So in how many ways can Shane dress himself? So let's just keep in mind that when it comes to dressing himself, he needs to choose a shirt. Okay, the shirt then can be associated with maybe a pair of trousers. Okay, and then he needs to also choose a pair of shoes. Okay, so once again, this is I suppose counting rule number 2 again. Okay, for each selection, okay, from a particular bag, okay, there's a number of objects in each of the bags. We have to choose something from our bag of shirts, something from our bag of trousers, and something from our pair of shoes. Okay, so once again, for respect to shirts, he's got 8 choices for shirts. So the number of possibilities is he's got 8 choices for shirts, and with each one of them he can have a selection from 4 pairs of trousers. Okay, and with each one of these possible pairings he can select a pair of shoes from 5 possible pairs of shoes. Okay, so in this particular example here, well, what we got, we have 4 eighths is going to be equal to, so we have 4 by 8 gives us, we have 8 by 4 gives us 32, and multiply that by 5 gives us a value of 160. There's 160 possible ways that Shane can dress himself. So there's 160 possible outfits, let's say, with respect to the way Shane can dress himself. Okay. Another typical type of question that you could have, another example, okay, is something like this, okay, is that let's say maybe, let's say there's seven books on a shelf. Okay, so there's 7 books on a shelf, and we want to know in how many ways, okay, can these books, okay, books be arranged. Okay, be arranged. Now, the key thing here is that we want to arrange all the books. Okay, so we need to arrange all the books. We're going to assume that they're all unique as well. There's no other information given here, so we can assume that they're unique. Okay, so we need to arrange everything. So this is counting rule number 3 that's coming into play here. Yeah. Okay. Don't forget, counting rule number 3 said the number of ways that all n items can be arranged, okay, is simply equal to n factorial. Okay, that's really important for us here. Counting rule number 3. So we have 7 objects, and we want to arrange them all on the shelf. Okay, so it's basically n factorial. Okay, it's n factorial. So we have 7 objects. Don't forget, when n is equal to 7, we have it's 7 factorial, which gives us, is that 4,000? 7 factorial. 7 factorial is equal to 5,040. There's 5,040 possible ways to arrange 7 books on a shelf. Okay. So let's see what else we can do here. Okay, maybe I'll just move my counting rules out of the way there. Okay, let's have a look at another example here. Okay, let's say we have something else. Okay, let's say we have something a little bit similar. Okay, so an example. Okay, let's say there are 8. Let's say. Let's say there are 8 children sitting on a bench. Okay, so let's say there's 8 EIGHT. There's 8 children. There's 8 children sitting on a bench. Okay, in a bench. Okay, in how many ways? Okay, can they be arranged? Okay. In how many ways can they be arranged? Okay. So once again, there's 8 people. We want to arrange them all. So once again, this is counting rule 3. When we use all the objects, okay, and every single object is used out of the collection of objects, it's simply n factorial. So once again, we have 8 children, and they all need to be arranged, so the answer is going to be 8 factorial. So now how many ways can they be arranged? Well, it's given by 8 factorial. So 8 factorial in this case is equal to, well, it's 8. Second function, my factorial function here, gives us this 40,320 different arrangements. Yeah, arrangements. Okay, arrangements, yeah, okay, with respect to those particular 8 children. Okay, let's make it a little bit more complicated. Yeah, in how many of these arrangements are the 2 oldest children always together? Okay, so let's make this a bit more complicated. Yeah, in how many ways? Okay, can